Hello everyone, my name is Albert Joseph, and today I will be your walkthrough through homework number 6 of MECH 3380, Intro to Computational Design and Analysis. Now for this homework, we're required to use Abacus, but it doesn't matter if you use the personal student version on your own laptops or the versions provided at UTD in the computer lab. So with that being said, let's get into it. So for problem 1, we're asked to run a simulation on a cargo crane in order to figure out the static deflection. Now, you do have the option of either completely making this crane from scratch yourself, or you could utilize the model provided through the online tutorial. So I tried to make the crane myself from scratch, but I decided it was too time consuming, so I decided to use what was already provided. Now, what we have here is two ways to access that provided version. Now we can either run a Python script or we can use a plugin script. This was the option I went in with. So as we see here, we simply select the plugins in Abacus and getting started, and then we simply highlight the cargo crane and hit run. Over here, this is where you access the plugins. Now, when you have the file open, when you have the provided file, it's still important to utilize the walkthrough the professor shared towards the beginning of the semester, but in the walkthrough you can skip all the way to post-processing. From there, we can get on with making the task of the first homework, which is to get figure 625. So what we want to do first is to submit the job, so to run it, and then we click the results to access the result tab. Now, when we first get to the results tab, it currently just shows an undeformed version of the crane. To get the both undeformed and deformed, you have to click here and then click the deformed tab to get the isometric view of both views. But then, in order to make it more like figure 625, what we do is simply go to view and then hit the taskbar to get views, and then we get this tab, and we select the XY plane to make our view most similar to figure 625. From there, hit Control P, and then you'll get your submission for the first part of question 1. Now that we've got our plot of the deformed shape of the model for 625, you would think we can simply skip all the way to creating a bending moment type contour plot for figure 628, but that's not exactly the case, as we still need one important item. So right after the step of forming the deformed shape for figure 625, what we do next is to shift click all the items in truss A. In this case, it's in the XY plane, it's the side that's facing you, and we only select the outer edges. So don't forget to shift click, so the end result should end up looking like this. Now when that's done, we simply click the replace button right here, and then to get the create display group dialog box, we click over here, and then we simply name this as main A and dismiss, and then we should have our new group. Now we should currently be set on the main A group, so what we do now is to go on the field output toolbar, the left side, and select primary. It should already be set there, but what we do in the center is to change it to SM, and the very right should automatically turn to SM1. Now we open the common plot options right in this corner, and from there we select a uniform deformation scale of 1, and also we want it to be uniform, so it should be set like this. When you finished applying and click OK, you should get figure of the contour deformation. And I should have mentioned this earlier, but when opening the provided version, the file name should be crane.cae. Now we move on to the crane under dynamic loading. Like the previous example, you either have the option of making this from scratch yourself, or you can utilize provided files once again. And I too used the provided files, so I used the same method for the previous one to open it, but instead the file name you should look for is dynecrane.cae. When we have it opened, we notice that in this case there are two jobs. For safety's sakes, we want to submit both of them, but however, I only looked at the results of the first one. Now that we're in the results tab, what we do is select this frame selector tool on the far right corner, and this box will appear. Now, to get your mode 1 and 3, you have to slide this to 1 and 3 respectively, but you want to make sure that the deformed version is showing. to do that, you simply click here. Now, something I want to point out is that my node 3 looks a little unusual on this end, as the two trusses are intersecting, whereas that's not the case in the PDF or the online tutorial version. It might be due to me using the school computer. Now to determine the peak pullout force. What we do here is to go to the history output, and which we can find by expanding the output data bush tree and select history output. Then we right click it and select filter and enter apostrophe RF1, and as a result we'll get these 4 reaction forces. Now we control select all 4 of them and select plot by clicking right click first, then select plot, and we get this graph. Now simply follow these instructions to resize and reposition the grid and legend. Now the main task is to query it, so from the main bar we select tools and then select query, and this box will open up and we select probe values, and then according to the figure we select around this point. Now to be honest, I haven't exactly found a way to save this part as part of my file for the history output, so thanks for tuning in with me, and hopefully this homework will turn out great for the rest of you.